Okay. It's time now for some awards. So first award, which I'm going to present, is the Most Influential Paper Award. So this is an award that's given each year to the most influential paper from 10 years before. So this is the award for the 2009 Most Influential Paper. And I am very pleased to present this award to Cristiano Calcagno, Dinos Di Stefano, Peter O'Hearn, and Hong Sok Yang. And if any of you are here, would you care to come up and let us applaud you? Great work. Let me, since the type there is small, let me read you the citation. And after I do that, I'm sorry I didn't warn you this, but if anybody has anything to say, I'll hand you the mic for a short comment. So the paper that they wrote is called Compositional Shape Analysis by Means of Biabduction. And the citation goes like this. Shape analysis is the problem of precisely predicting at compile time the contents of mutable pointer-based data structures. It holds the key to identifying and hence eliminating a wide variety of classes of software defects, from null dereference errors to use after free bugs and memory leaks to subtle data races that complicate concurrency. This paper showed how to use compositionality to scale shape analysis up to large code bases by introducing, quote, biabduction, a new technique for analyzing each procedure in isolation, independent of its callees. Biabduction allows an analysis to determine separation logic preconditions under which the procedure executes safely, and corresponding postconditions that describe how the procedure mutates the heap when it's executed from a configuration satisfying the precondition. We can then use separation logic to compose the pre and post conditions for different functions, yielding the first precise shape analysis capable of running on millions of lines of code. This work directly led to the development of the infer static analyzer, which has been used to find and fix tens of thousands of defects across multiple industrial code bases. Further, it rekindled interest in the notion of abduction, leading to new techniques for interactive exploration of the results of static analysis and compositional program synthesis. Good work, guys.
Right, so thanks very much. So maybe the most important thing about this work was the question asked in the beginning. So daring to dream that something much more could be done than what was currently possible. So I'll give you a little story. So the four of us were in a cafe in the East End of London, a very funky area of London, right? And Cristiano was very dissatisfied with the state of the subject at that point. And he said, so at that time, it was difficult to run one of these analyses trying to prove memory safety on 1,000 lines of code. And Cristiano said, what's the main thing stopping us from going for 1,000,000 lines of code? And you might wonder, so we discussed this and we all made contributions in order to reach that goal. But that question was so critical. To go from 1,000 to 1,000,000 seems quite outlandish. And he even had on his blackboard, written in large letters, go huge or go home. He was only interested in big code. Now, why was he interested in this? Is because Cristiano and Dino, they wanted to start a company. We did write a POPL paper, but the goal wasn't to write a POPL paper. They wanted to start a company, and they wanted to be able to analyze the millions of lines of code that you would find in the major companies. So they took this as the aim, and then we found some techniques such that we were able to do it. But without that initial drive from these two guys, then we never would have thought of those techniques. So that my message to you would be, like, dare to try problems that are far beyond what can be done in the academic literature at the moment.
Here, here. Congratulations.
Do you want to?
Okay, and now I'll turn it over to Mira for the next award.
Thank you. So the next award we want to announce today, or actually there are two awards, is the John Reynolds Distinguished Dissertation Award. This award is given every year for the best dissertations in the area of programming languages for that year. So these are dissertations that were awarded last year in 2018. And the committee this time, it seems like, couldn't decide between the two. They were both very good. So there were two awards. One of them, the first one, on practical formal techniques and tools for developing LLVM peephole optimizations, was the PhD by David Menendez. He did that PhD at Rutgers University, and the recipients of the award can decide where to receive the award, where the award should be presented. And David wanted to have it presented at UPSLA. So this was presented at Splash in Boston last year in November. So nothing new here for those, at least, that attended Splash. The award I am going to announce today is for the dissertation by Justin Su. I hope I pronounced the name good. Okay. On probabilistic couplings for probabilistic reasoning. So Justin, would you mind coming up here? Right. And I'm going also to read the citation. The thesis explores and generalizes the coupling proof technique for establishing properties of randomized algorithms. A correspondence between two different probabilistic programs or two different runs of the same program requires a specification of the correlation between corresponding pairs of random draws, and then extending this coupling to from samples to a coupling on the resulting output distributions, which can then be used to establish the desired property on the programs. As probabilistic relational Hoare logic has just the right structure to be able to formally encode these coupling arguments, the thesis by Justin analyzes the structure of these arguments through this formal lens, justifying the attractiveness of the coupling approach in terms of compositionality. It then considers an enriched logic and its connection to approximate couplings, which in turn are directly connected to differential privacy. Working in this logic, it gives novel proofs of some key constructions from differential privacy, including the exponential and sparse vector mechanisms. The proof for sparse vector is the first ever to be carried out in a machine checkable form. So to sum up, taken together, these results constitute a significant advance in our ability to mechanize key properties of important randomized algorithms, such as those found in differential privacy literature. Sounds like a great job you did with your thesis. So congratulations.
I wanted to thank the committee for selecting me, and also David Menendez for this award. It's a real honor. There's a lot of great theses in this, I guess, in the previous awards, and I'm really thrilled to be kind of one of this one's for this year. There's many people I'd like to thank for this award and kind of for collaborating with me during my PhD. But I want to thank, I guess, three people in particular. So first of all, my advisors, Benjamin Pierce, who many of you know, and also Aaron Roth, who some of you probably don't know. So Aaron is a researcher in differential privacy that just started at the same time as a professor when I started at Penn. So kind of that synthesis of kind of two different lines of research can maybe be seen a little bit as a result of this thesis. Last but not least, I'd like to thank Gilles Bart, who served as kind of my third kind of unofficial advisor. I did mentoring internships at IMDEA, and kind of a lot of the work in this thesis is done in kind of collaboration with him. So thanks a lot.
And with this, I'll pass over to... Sorry, I forgot.
All right. Hello, everybody. My name is Brigitte Pientka. I will be General Chair of POPL 2020, and the location will be, oops, that's the wrong direction. Oh no, that's the wrong direction at all. Okay, this is the right direction. Okay, so yes, it will be in New Orleans in January, so I'm very excited about it. I just visited New Orleans in fall, and it was great. There's lots of restaurants, wonderful restaurants, lots of music, a lot of fun, but I'm also excited about the conference hotel because I think it will be a great venue for us to have this event. It has a nice balcony where we can hopefully hang out a little bit while discussing all kinds of cool things we heard in these talks. We signed the contract, so the room rate is hopefully also competitive. And it's right next to the French Quarter, so it's really like a 2-minute walk away where you can sort of hang out and enjoy. We started coming together with our organizing committee, in particular the PC chairs, Lars Birkedal, who says hello, and it expects lots of submissions from you. He couldn't come today, but he has done already quite a lot of work. Some of the chairs who have been helping to make POPL a success this year are also staying on, so I'm very grateful for that. And some of the people I also talked to already here who will be maybe joining us for the next year. So I think we're in good shape so far. And Lars has done so far already a big job, namely he has been assembling the PC, and these are all the people who agreed to be on the PC, and I'm really delighted about this PC because it is very broad in the topics, in the areas where people are coming from, research areas, as well as physical locations where they're based. And so I think it will be really an interesting program that will eventually emerge out of all the submissions you hopefully will submit. So stay tuned. The website will be up sometime in February, I think. And then hopefully you all come to New Orleans. Sorry? What if you can't? Then you still can join us online as we have here a video feed, and we feel very sorry, and we will think of you. Any more questions? All right, that was short and sweet.